Hi folks, we're going to take a look at question number 11 from page 55, and the question gives us three vertices of a parallelogram, and they want us to find all possible locations of the fourth vertex. So the first thing I did is I just drew myself a diagram here, and you'll notice that I didn't even worry about being accurate as to where these points are. This is just to help guide me to set up the problem. So the first thing we have to do is we've got to figure out how many possible points there could be. So I drew these three here, and looking at that I see, well, if this is one of the sides of my parallelogram, I could have a side that's opposite, which would be parallel, same length. So somewhere here, okay, would be point 1. So let's call it that. In fact, let's put an X on it so that we can distinguish it from the given points. Okay. Well, notice if I take this side again, I can also create an opposite side on that point, from that point here, on the other direction. Okay, so there we go. There's another possible point. So we'll call this P2. Okay, and I look here, and if I take this line, well, I can create a second line over here to create a parallelogram. So parallel side with the same length. So there you go. So there's a third possibility. Okay. Well, I could take this side here and start from point 5,2, but then I realize I've already gotten that point into play. Okay? And I realize that these are the only three possibilities. So first and foremost was to determine that there's three possible points. Now we have to come up with a way to determine what these points are, and I'm going to use the fact that parallelograms have opposite sides that are parallel and have the same length. So in order to work with this idea of parallel and same length, I'm going to use the idea of vectors. So if I draw a vector from, let's say I call this point A, I call this point B, and I call this point C. If I draw a vector from A to B, I know that the vector from C to, say, this point P1 will have to be the same vector. In other words, same magnitude, same direction. Okay, so in order to find P1, I know that vector AB has to be the same as vector CP, or CP1 in this case here. Now, since I don't know what point 1 is, well, let's call it XY. Okay, since I'm only dealing with P1, I'm going to call it XY. So now what I can do is I can create these two vectors from one point to the other. So I'd create the vector from point A to point B, and I know that I can do that by subtracting the second minus the first. So 5 minus negative 5 is 10, and then 2 minus 3 is negative 1. And that has to be equal to the vector from C to P1. Okay, so it's second minus the first. This gives me x minus 7, and this gives me y minus negative 8, so y plus 8. But since these two vectors have to be equal, I know that the x components have to be equal, so x minus 7 has to be equal to 10, and I know the y components have to be equal, so y plus 8 has to be equal to negative 1. And I can solve this. Okay, 10 plus 7, 17, and here negative 1 minus 8, negative 9, so the point P1 would just be equal to 17, negative 9. Okay, so I found my first point. Let's now work with P2. Okay, well, I still need to work with this side here, so I can still go from A to B, but instead of going from C to point 1, I'm going to go from point 2 to C. So now these two vectors are the ones that are going to have to be equal in order to get these opposite sides that are parallel and the same length. So for the second point, I'm going to say that vector AB has to be equal to the vector P2 to C. Okay. Now, since I'm working with a completely different point that's not related to the previous one, I'll call this one again XY. So now, again, we already know the the vector AB. It's 10, negative 1. And now the point P2 C, well, going second minus the first. So here we have 7 minus x, and then here we have negative 8 minus y. So again, since these two vectors are equal, we know the x components are equal, so 7 minus x has to be equal to 10, and negative 8 minus y has to be equal to negative 1. So I'll bring the negative x to the other side, so x is equal to 7 minus 10 is negative 3. Then here we'll bring the negative y to the other side, so y is equal to negative 8 plus 1, which is negative 7. So my point P2, my second possibility, is just equal to negative 3, negative 7. Okay. Let's now look at this last possibility. Okay, so if I connect the vector C to B, that should be equal to the vector going from A to P3. Okay, that'll then create my third possible parallelogram. So let's set this up here. So for our third point, okay, I'm going to take the vector going from C to B, and that has to be equal to the vector going from A to P3, which again, I'll just label xy. Since I don't know it, I use variables to represent it. Okay, so from A to P3. So the vector CB, so second minus first, so 5 minus 7 is negative 2. Okay, and here 2 minus negative 8, 2 plus 8 is 10. And let's do A to P3, so second minus first, x minus negative 5 is x plus 5. And then here, second minus first, y minus 3. Okay, and now that we have that equation, let's just move down to solve it. So again, the x components have to be the same, so x plus 5 is equal to negative 2, and here y minus 3 has to be equal to 10. Let's solve this. X is equal to negative 2 minus 5, negative 7, and y is equal to 10 plus 3 is 13. And so our third point is going to be negative 7, 13. Okay, there you go. There's all 3 points. So let's recap what we did. First thing, again, use a diagram. Notice again, I didn't have to be accurate at all. I could have done this with 3-dimensional points. So trying to draw an accurate diagram wouldn't have been helpful anyways. But the idea was to first figure out how many possible parallelograms we could have. Here we saw there's one parallelogram, there's another parallelogram, okay, and then the third parallelogram was 1, 2, 3, 4. So 3 possible points, okay, and we use this idea of connecting the points with vectors, okay, to create pairs of equal vectors, which we then use to solve for the individual x's and y's for each point. Okay, that's it for now.